Hello viewers, welcome to cbse Maths class. In this class, I'll be explaining how to learn the trigonometric identities of a class 10th syllabus in easiest way. The same figure I have used in the previous video to explain you about the trigonometric functions and its reciprocals. So the same figure I have used here also to make you to learn about the trigonometric identities, that is sin square a plus cos square a equals 1. From sin square a plus cos square a equals 1, there are two sub-formulas. 1 minus sin square a equals cos square a, and 1 minus cos square a equals sin square a. 1 plus tan square a equals secant square a, second identity. 1 plus cot square a equals cosecant square a, third identity. From the second and third, we can write the fourth and fifth identity. By transposing tan square a to RHS, secant square a minus tan square a equals 1. Similarly, cosecant square a minus cot square a equals 1. These are the 5 very important trigonometric identities which are used in solving the problems connected to the word problems, that is long answers question. Even very short answer questions also will be asked based on these identities. So how to remember all these identities without memorizing it? Just with the help of the diagram, I will make you to learn. See, on each vertex of this hexagon, I have used the square of one trigonometric function. That is sin square a, cos square a, tan square a, secant square a, cosecant square a, cot square a. And the middle of this hexagon, there is a circle containing 1. So we will see how this figure help you to learn these identities. The first identity is sin square a plus cos square a equals 1. You observe the sin square a and cos square a, the two consecutive vertices of this hexagon. I have written sin square a and cos square a. So sin square a plus cos square a. You can write sin square a plus cos square a. The two consecutive terms of this, if you add it, sin square a plus cos square a, their sum is equal to 1. Sin square a plus cos square a. This is plus not into. Sin square a plus cos square a equals 1. Again, from this, how to write sin square cos square a equals 1 minus sin square a. So 1 minus cos square a. So 1 minus cos square a is equal to sin square a. Similarly, 1 minus sin square a is equal to cos square a. So these three formulas you can learn by considering the two consecutive vertices trigonometric functions which are written in the figure. That is sin square a plus cos square a is equal to 1. 1 minus sin square a is equal to cos square a, and 1 minus cos square a is equal to sin square a. So the first identity we have completed along with its two sub-formulas. That is 1 minus sin square a equals cos square a, and 1 minus cos square a equals sin square a. 1 plus tan square a is equal to secant square a. In the figure, observe where are these tan square a and secant square a. Tan square a and secant square a, again, once again, they are the two consecutive terms which are written on the vertices of the two vertices of the hexagon. 1 plus tan square a. So 1 plus tan square a. I am adding 1 plus tan square a. 1 plus tan square a is equal to secant square a. Okay, 1 plus tan square a is equal to secant a. From the figure you observe, 1 plus tan square a is equal to secant square a. And then 1 plus cot square a, 1 plus cot square a is equal to cosecant square a. So that means we have completed the second and third also. Secant square a minus tan square a equals 1. Secant square a minus tan square a is equal to 1. Okay, so secant square a minus tan square a, 1 we got. Similarly, we have cosecant square a minus cot square a. Cosecant square a minus cot square a. Here it is minus. Cosecant square a minus cot square a is equal to 1. So that means fourth and fifth identity also we have completed. So there is no need to by heart any formulas related to identities here. Just with the help of the diagram, you can remember all these 5 trigonometric identities, and let us see how these identities are useful in solving the problems connected to trigonometry. Let me take the first question. Okay. What is your first question I'm considering here? Prove that sine to the power of 4a minus cos to the power of 4a is equal to 1 minus 2 sine square a, which is also equal to 2 cos square a minus 1. Okay. Let us take the first part and prove sine power 4a minus cos power 4a equals 1 minus 2 sine square a. So let us take first part. What is first part in the question given to you? Sine to the power of 4a minus cos power 4a. Okay. So let me write without altering its value, sine to the power of 4a as sine square a whole square minus cos to the power of 4a as cos square a whole square. Don't you observe some formula in this condition now? Consider sine square a as a and cos square a as b. Don't you see it is in the form of a square minus b square? What is the algebraic identity connected to a square minus b square? That is a plus b into a minus b. What is a and b? Understood now? A is equal to sine square a and b is equal to cos square a. So when you use sine square a and cos square a, so what you are going to write in the next condition? So I can write this condition as sine to the power of 4a, sine square a minus cos square a whole square as a plus b. That is sine square a plus cos square a into sine square a minus cos square a. I've used a square minus b square as a plus b into a minus b. So already the first identity says sine square a plus cos square a. What is the sum of this sine square a plus cos square a? Sine square a plus cos square a will give you 1 plus 1 into sine square a minus cos square a. Sine square a minus cos square a. Since sine square a plus cos square a has become 1. So 1 into sine square a minus cos square a will give you sine square a minus cos square a 1. Cos square a only. So you did not get any one of the required answer. That is 1 minus sine square a also you did not get, and 2 cos square a minus 1 also you did not get. So what we will do here, in the second part, what you are supposed to get? 1 minus 2 sine square a. That means we don't require cos square a term. So cos square a shall be replaced by 1 minus sine square a. So what will happen in the next condition, shall we see? Sine square a minus cos square a can be written as 1 minus sine square a. Okay. So which is equal to sine square a minus 1, and minus of minus will become plus sine square a. So which is equal to sine square a plus sine square a is equal to 2 sine square a and minus 1. Let me make little change in your condition. That is, we'll write the reverse here. You are supposed to prove sine square a minus cos square as 2 sine square a minus 1. 2 sine square a minus 1. And here you will write 1 minus 2 cos square a. There it is. 1 minus 2 cos square a. It is 1 minus 2 cos square a. So the first condition we got from sine power 4a minus cos power 4a is equal to 2 sine square a minus 1, and keep this equation number 1. So we have proved the first. From taking first part, we have arrived at the second part. Shall we take the second part and arrive at the third part by taking 2 sine square a minus 1. 2 sine square a minus 1 is equal to 2 into, shall I change sine square a in sine in cos form? Sine square a is nothing but 1 minus cos square a. Close the bracket and minus 1. So when you open up the bracket, 2 into 1, 2, minus 2 into cos square a, 2 cos square a, and minus 1. So bracket is closed here only. No need to multiply 2 into minus 1. So what is your next step? You are going to, what is the next step? 2 minus 1 gives you 1 minus 2 cos square A. And keep this number 2. So from equation number 1, 2 and 3, from equation number 1 and 2, and the given condition we have used sin power 4a minus cos power 4a. Therefore, what you are going to get, sin raised to the power of 4a minus cos raised to the power of 4a is equal to 2 sin square a minus 1, and that 2 sin square a minus 1 is also equal to 1 minus 2 cos square a. So this is how we have proved this problem by making use of the trigonometric identities. Some more examination oriented problems I'll be discussing in the coming video. That's all from this video. Have a good day.